Yeah, my name is Lav Kumar HN, Department of ISC, SVCE, Bangalore. So today I'm going to discuss about how buffering is managed in OS and some information about buffering. So without further delay, let's get into the video. So today I'm going to explain about what is buffering in operating system, reasons of buffering, types of buffering, how buffering is managed in OS, advantages of buffering, limitations of buffering, and conclusion. So first, let's discuss about what is buffering in OS. So basically in operating system, buffering is a technique which is used to enhance the performance of input-output operations of the system. So it is mainly based on input-output operations. Basically, buffering in operating system is a method of storing data in a buffer or cache temporarily. In operating system, it's a method. So to store this method is used to store some data for some amount of time, that is temporarily. This buffer data then can be accessed more quickly as compared to the original source of data. So this buffer is very useful to get as speed as when we require this data, we will get it easily. So let's see what is the original source of data, how we will get it. That is, in a computer system, data is stored on several devices like hard disks, magnetic tapes, optical disks, and network devices. In the case when a process requires to read or write data from one of these storage devices, it has to wait while the device retrieves or stores the data. This waiting time could be very high, especially for those devices which are slow or have high latency. So in general, we have computer system. So here data is stored in several devices which are hard disks, magnetic tapes, and optical disks, and network devices. In this case, when a process requests to read or write data from one of these storages, so to retrieve the data from these devices like hard drives, disks, magnetic tapes, optical disks, and network devices, it has to wait. We need to wait for some amount of time. So when we need to get some data, we cannot. When there is a urgency for get some data, it's it's an disadvantage. So to replace this, we use this buffer and buffering method. This problem can easily addressed by buffering. So buffering provides a temporary storage is a called buffer. So this buffer is temporary and it is not permanent, and it is very faster than the actual data we are going to get. Buffer can store data before it is sent to or retrieved from the storage device. So buffer will store some amount of data and it will pass the data when user requests that. So and when the buffer is fully occupied, so suppose if the buffer is full, so buffer is having some limitations, so limit of data. So after that it will store. After completion of that, if that is fully occupied, then data is sent to the storage devices in batch. So these storage devices we have seen in the previous line, that is hard disk, magnetic disk, tapes. For this it will transfer. This will reduce the number of access operations required and hence improve the performance of the system. So this will help to improve our operating system performance. This is the main advantage in using buffer, and this is what we buffering in operating system. So now let's see about reasons of buffering. There are three major reasons for buffering. So one is buffering creates a synchronization between two devices having different processing speed. For example, if a hard disk has high speed and a printer has low speed, then buffering is required. So for example, it is like two devices. It will work when the two devices are available. For example, if two devices are having same uh, efficiency, or it's having same processing speed, then it won't work. When it is required means if the one device is having high processing speed and another device is having low processing speed. In this case, we need this buffer. And buffering is also required in cases where two devices have different data blocks. It's also same like if one device is having more storage and it's having more data and one device is having less data. In this case also we use this buffering. And buffering is also required to support coffee semantics for application input output operations. It's mainly required in the operations of input output operations. These are some reasons so when we want this buffering. So now let's see about types of buffering. So in operating system, there are three types of bufferings are there. They are single buffering, double buffering, circular buffering. Now let's discuss briefly about these. Sing now single buffering. It is the simplest buffering that the operating system can support. In the case of single buffering, when a process issues an input-output request, the operating system against a buffer assigns a buffer. It's not again, it assigns a buffer in the system portion of the main memory to the operation. Then the input transfer are made to the buffer and are moved to the user space when needed. So it's where this is what single buffering, which means it works on input output request. So when someone wants some output from the system, so here some if you want something in these cases, this single buffering will work. When it comes to double buffering is an extended variant of single buffering, and in this buffering a process can transfer data to or from one buffer while the operating system removes or fills the other. Therefore double buffering has two systems buffers instead of one. So it's an extended version of single buffering, which means updated version of double buffering. And it's also same, it will work on input output operations, and also it will work on some processes. Now let's see about circular buffering. When more than two buffers are used, then it is called circular buffering. it, if many buffers, I mean more than one or more than like two three buffers are used, then it is called circular buffering. It is used to solve the issues associated with the double buffering technique. Sometimes the double buffering becomes insufficient when the process performs rapid burst input output in the circular buffer. Each individual buffer acts as a unit. Here we are going to use that circular buffering, which means if suppose this we have seen in previous slide that double buffering and single buffering may not sufficient for some processes. So in this case, we need this circular buffering. So these are some types of buffering. So now let's what we need to see, that is how buffering is managed in OS, how it's going to manage. So that is buffering is a fundamental mechanism in operating systems to optimize input-output performance. It involves temporarily storing data that is being transferred between different components of a system. So these components are disk and CPU, or a network and a processor. And the aim of the buffering is to improve the overall efficiency of input-output operations by reducing the number of physical transfers required. So here in first point, it's mentioned that it will improve the overall efficiency of input-output operations. And next, in general, there are two types of buffering that can be used in an OS. Those bufferings are block buffering and character buffering. So these buffering which we can use in operating system. So block buffering is used when data is transferred in large blocks, such as when reading or writing files. And this character buffering is used on the other hand is used small scale operations. The character buffering is used for small scale operations, and this block, it contains block of buffer. So this block buffering is used for large scale operations, such as the small scale operations are keyboard input or printer input. These are some small scale operations. Next, when the management of buffering in an OS involves several key components. First, there is the buffer pool, which is a region of memory that is allocated for buffering purposes. This pool is typically managed by the operating system kernel and is shared among all applications that require it. So, the management of managing of buffering in operating system involves several key components. So, these are buffer pool and memory. So, these all are some key components we need to look. So second, there is a buffer cache which will store some data, blocks of data. This cache is maintained by the file system and is used to improve the performance of disk IO operations. The buffer cache is organized as a set of buffers, each of which corresponds to a particular disk block. So this is the second what we why we use this buffer and how it will be managed by the operating system. Next, when it's third way is there is a buffer manager which is responsible for allocating and deallocating buffers as needed. The buffer manager is typically part of the OS kernel and is responsible for managing the buffer pool and the buffer cache. So in every operating system, there will be a buffer manager which will manage the buffering. And finally, there is a buffering policy which determines how buffers are allocated and used. The policy is typically configurable and can be turned to optimize performance for different types of applications or workloads. In operating system, we will do different types of operations. So for these different types of operations, we need to have different types of buffer. So this buffering policy will determine the which buffer is used for which application, which operation. Like this, it will allocate the buffer. In summary, finally, we can tell that buffering is a critical component of a modern operating system that is used to optimize input-output performance. The management of buffering involves several key components, including the buffer pool, the buffer cache, the buffer manager, and the buffering policy. By properly managing these components, an operating system can provide efficient and reliable input-output operations that are essential for a wide range of applications and use cases. So this is what we have discussed till now. All these points have kept as a one point. This is a summary of what we have discussed till now. So next we are going to see about advantages. So the some of the important advantages of buffering is buffering reduces the number of input-output operations required to access data, and buffering reduces the amount of time for that process have to wait for the data. Buffering improves the performance of input-output operations as it allows data to be read or written in large blocks instead of one byte or one character at a time. Buffering can improve the overall performance of the system by reducing the number of system calls and context switches required for input-output. So you have understood that the main advantage of buffering is the retrieving of data is speed. It will faster than the other previous things, and it's very advantageous. And some of the limitations are also there. These limitations are buffers of large sizes consume significant amount of memory that can degrade the system performance. So in some conditions, the buffer will occupy more memory, so which may degrade the system performance. It will affect the system performance. It is one of the limitations, and buffering may cause a delay between the time data to read or written and the time it is processed by the application. So some of the time delay, we face some time delays in some conditions, so we cannot get that required data. What we are expecting time may delay, and buffering may also impact the real-time system performance and hence can cause synchronization issues. So buffering may it will impact real-time system performance, so it will impact the system's performance, and it will cause some synchronization issues when it will deal with some other device, so it may have some problems. So these are some limitations of buffering. So let's come to the final part, that is conclusion. That is, to conclude, buffering in operating system is a technique that is used to avoid overheads and inefficiencies in the system. This is the conclusion what we have discussed till now, and this is the end of my presentation. And if you like my content, if you have get something from this video, you like my video and you share with your friends, and do that subscribe and click on that subscribe, and you can get notifications when I upload some of my videos. Thank you for your time.